Hey, my name is Christopher Guzman, Senior Technical Artist here at WisE Engineering. In this video, I'm going to go over some tips and tricks on how to optimize your scene for VR. The first thing we want to do is, as soon as you open your project or you're going to start a new project, you come into settings and then go down into project settings. Second, we're going to go down into rendering, which is right here. We want to make sure that mobile HDR is unchecked and the mobile MSAA is disabled as well as of right now. Depending on your performance, you can actually increase this, but for the time being, let's turn it off. And the reason for this is because mobile HDR is best used for HDR lighting features and post-processing. Both of these features are not supported, or the cost in VR is very high. And even if you don't have the effects turned on, the overhead of having this option on is calculated in the GPU regardless, so your performance will suffer. And for MSAA, we turn it off because with it on, you get a performance hit. But while we build our game, we want the raw performance numbers of the game itself without overhead of any other processes. Then, after you get your raw numbers, you can start enabling things like anti-aliasing. And that's when we turn on MSAA. Another option that we want to make sure is checked is forward shading. We want that enabled for VR. And the reason to enable forward shading is because it provides a faster baseline with faster rendering passes, which may lead for better performance on VR platforms. Not only is forward rendering faster, it also provides better anti-aliasing options than the deferred renderer, which may lead for better visuals, like MSAA is only available for forward shading. Next, we want to go into general and make sure that in the tab frame rate, move frame rate is unchecked and use fixed frame rate is unchecked as well. Also check that custom time step is set to none. And this is so that you can see the actual frame rate of your game. And for now, those are the project settings that you will want to have to start the project. You can also visit the Unreal Engine documentation where they go over all the settings that you will need for an optimized VR scene. And they go over all the settings that I just mentioned, as well as many more. Now let's jump into some of the commands that are used for optimization. In this test scene, I will demonstrate some of the commands that are used to look at performance. Once you have completed your scene, we want to see what the performance is like. To get some basic numbers, we want to use the console commands to input some of the commands and get some information out of it. To open the console command window, we could go either to the window, developer tools, output logs, or we can hit the tilde key. You will see the console command open at the bottom of the screen. Since I have multiple monitors, I have most of the windows used for performance monitoring opened, as you can see here. I use the output log window, the device output log window, and the merge actor window. The output log window has a console command bar attached to it, so it displays information on what is going on your scene, as well as you can input some commands to it. The device output window connects to your device, in this case the Oculus Quest, and you can send commands to the headset itself to display information like in the editor, as well as extract information from the headset. The merge actor window is to merge meshes together, as well as textures in the editor to reduce draw calls. Let's start by opening the console command and type our first command, StatFPS. That will show us both the final number of FPS and the time it took to render the last frame. This is just a general view of the performance and it does not show us the full picture of those numbers. Now let's bring up more information to get a better understanding what's going on. Let's type stat unit or stat unit graph. This will bring up a HUD or heads-up display that will show us the performance of the game in milliseconds per frame. The information offered here can serve to determine where we're having performance issues. The only difference between the two commands is that one shows us the numbers while the other command shows us the graph and color codes the different numbers so that we can identify them in the graph. So we have frame. This is the time it takes for each frame to render. It's almost the same as FPS. The next one is game. This is the time it takes for your code to process. Either it could be C++ or blueprints. Draw. This is the time it takes the CPU to prepare the data to send it to the GPU. And GPU is the time it takes for the GPU to render each frame. Everything calculates in milliseconds, like I stated before. For performance of 72 frames per second, which is the ideal for an Oculus Quest, you need to target at least 13.88 milliseconds per frame. And since we need a bit of overhead for these spikes that presents in the game, we lower that to around 10 milliseconds, 10.4. So any number around the 10 to 11 mark and below are good indicators that we're hitting the performance mark. Now that we have some basic information on what's going on in our scene, we can take a look at some of the other commands. Let's start by typing stat scene rendering. This command is good to identify bottlenecks in the overall rendering pipeline. It will give you the time it takes for each process. This includes dynamic lighting, translucency cost, draw calls, lights in the scene, among many others. It will display the process in milliseconds as well, like every other command looking into performance. Also, another quick note, if you want to remove any of this heads-up displays, all you need to do is type the command again. And if you press the tilde and press up, you can just select which last command that you picked and click enter, and it will delete all those heads-up displays. Now we can head over to two similar commands, StatGPU and ProfileGPU. StatGPU will show you a heads-up display with the final numbers of each frame rendered, and ProfileGPU will show you in detail what happened to those frames with the time it takes for each process. This is good to identify what is causing the delay on the rendering of the scene. Here you can click on any process and it will give you a view and tell you what is going on with each process with the time it took for each of the tasks. Now, let's move on to another command that is very useful, StatRHI. It stands for Rendering Hardware Interface. This command displays how much memory you're currently using on each process. For example, how much memory the textures are using, how much memory the vertex are using, and so on. The most important values are rendered target memory. This shows you the total size of memory used in the game. This includes the information from the lighting and the materials or shadow maps. This depends on the game's resolution, while the shadows is controlled by the shadow quality settings. Another important value is triangle draw. This is the amount of triangle present at the moment, but it also counts triangles created by tessellation. So if you have a lot of tessellated materials, your count can increase exponentially. Another important value is draw primitive calls. Draw calls can be a serious bottleneck in DirectX 11 or OpenGL programs. They are the command issued by the CPU for the GPU. This shows the amount of draw calls at that current frame. This number includes decals, shadows, translucent lighting volumes, post-processing volumes, and more. Post-processing volumes are a major hit on performance for VR. So basically, we get rid of any post-processed materials and post-processed volumes that we are using to gain performance. For the most part, we fake anything that we can by either baking the material or baking the lighting and the post-process look into the texture itself. Now let's talk about texture resolution. For texture resolutions, let's take a look at some textures we created for our game.
You should have a specific resolution for your textures, and this is determined by the platform and the budget allocated for those textures. 2K maps and 4K maps are very heavy for the Quest to handle, so try to keep your resolution below 1K maps. For the hero meshes, you can use 1K, and for the props, you can use 512 or even 256, and even lower. This will keep the texture buffer low and the Quest will not struggle to render the textures. Let's open the content browser and click on the texture. We have a 2K texture and a 4K texture. Now you can see the size of the 2K texture, that is around 2 megabytes. This could add up very quickly, and if your budget for the textures, let's say, is 500, then you can blow up through your budget around 250 2K textures. And it's worse with a 4K texture. Let's take a look at this 4K texture. This one has a size of 10 megabytes, almost 11, which means that with 50 4K textures, you can blow up your texture budget really quickly. One other thing that you need to take in consideration is that a 4K texture will take 4 times longer to load than a 1K texture. So even if you have only one 4K texture, it will take longer to load that single texture than 15 1K textures. So keep that in mind when optimizing your game. If you bought a pack from the store, the textures most of the time come in 4K or 2K. Does it mean you have to export the textures out of the engine to reduce it? Well, no. Unreal has a compression settings built into it. You can set the maximum texture size you want any texture at. And you can also set the LOD bias and reduce the resolution on the textures. The way this works is on the compression settings tab, you can set the maximum texture resolution. This could be anything. So let's cap this one at 1024. As you can see, the size got reduced and the texture display and the max in-game texture is going to be 1024. Now, if you want to decrease the texture even further, because now the texture is set to 1024, you can use the LOD bias to reduce it even more. So if I set it to LOD 1, the texture, you can see it dropped to 512. If we bring it back down to 0, it goes back to the maximum texture size here. So you can play around with these settings. Another useful tool that you could use to look at all the texture sizes of your level is if you go into Window, Statistics, and here you're gonna see all the textures involved in this specific level and what is the size of each texture and the memory being loaded. This is another way for you to figure out what's the resolution of each texture in your game. And if you click on the object, it will take you to the specific texture so that you can adjust the values. Now that we have textures covered, let's move into occluded objects. Close this. One thing that you want to keep a lookout is for occluded meshes. This can be checked with 2 commands. The first one is StatInViews. This command will help you in measuring the cost and effectiveness of occlusion and frustum culling. Both of them are techniques used by the engine to improve performance. They dynamically hide meshes that would be invisible for the camera's position. In this list, you can see how many meshes are being occluded or being culled. Another command is freeze rendering. Freezes what the camera sees and occludes the rest of the meshes that are not in view. When you move around the scene, you can only see what the camera displayed at the time the command was entered. So let's do that. Freeze rendering. And you can see all the meshes were occluded. And then if I type it back, all the meshes come back. Another helpful command is rvisualize occluded primitive 1. When you click on this, let's turn off StatInViews. When you enter this command, what it will show you is a live representation of what's being occluded. And it's going to mark it with a green box. And as you can see, when I move around the scene, all those meshes that are not being seen by the camera are being occluded. So if I get behind any mesh, you're gonna see most of the room is being occluded. Then when I come out, they pop back into the view. And those are the 3 most useful commands. To disable occluded primitive, you have to type the same command, and instead of 1, type 0, and it'll delete those boxes. Now let's move into connecting the headset and pushing a build to it. Once you're able to build successfully to your headset, you can send commands through the device output log. Device output log lets you send commands to your headset from the engine. This is very important since the performance you're seeing in the engine is not the same as the one you expect from the headset. So how I stated before, you go into Windows, Developer Tools, Device Output Log. Since I have it in another window, I'll just move it to View. And now from here, once you have built and pushed the build into the headset, you can connect to the device. So let's connect to the device. And you see the device is connected. Now I can push any command that I want to the headset itself. I can do stat FPS, and you can see the UI with the FPS. And you can put any of the commands that we used previously. So we could use StatRHI, and everything will appear on your headset. The only command that will not work is CPU profile, because that's for the engine itself. So if I do profile CPU, you won't see anything because that's part of the engine, so it won't work for you. But every other command that shows numbers on your screen, those will work. Now to pull the performance information from the headset, you can use 2 commands. Stat start file with capital S and capital F. On this command, capitalization is really important. So now when you press start file, it will state that it is recording. So now whatever you do on the headset, when you move, when you interact, is going to be recording everything that you do and saving it to a file. Once we're done, now we can type stat stop file, and this will stop the file from recording and saves the file into the headset. But we want to get it out of the headset. The way to get it out of the headset is you need to open a command prompt window from the computer. So you go to start and type CMD and then open the window. Now that we have this, what we want to type is ADB Pull and the location where the profile is, and then the location where you want the file exported to. In my case, I'm going to put it on the screen so you can see the format on how this is written. ADB Pull, where the game is and where I want it stored. And when I press enter, it's going to start downloading the file. Once it downloads the file, it'll download a folder that has all your stats in them. Now that we have that, we want to go back into the engine. We close this and we want to move this out of the way, and we want to go into Window, Developer Tools, Front End Session. So now we go into Profiler, Load, we wait for the window, then we go into Desktop. We go into our profiling folder and we open our profile, and it's going to start loading up that file. Once you have that file loaded up, how I have it here, is you're gonna see a lot of spikes, and this is basically the performance of your game. So we want to go into you can click in this area and click on the spikes, and it will show you what is the time for each process. Since this is a test level, I don't have a lot of processes going on. All the spikes that I have are mostly on waiting on event. So that means that the game is waiting for something to happen so that I can finish that process. Most of the events are just that, is waiting on the CPU, waiting on the game thread. I don't have a lot of spikes on this one. So I'm gonna load another one, which is from my game itself. And once it loads up, you can see that it recorded everything on my game. So now I go to this area over here where it has a lot of spikes. And then I can click on these processes to see what was happening at that time. So you can see on this specific spike, it was waiting for the physics. So as you can see here, it'll tell you for the frame time of the game thread is waiting on the physics of the game to send the notification, and so on and so forth. This area right here, you can actually pick any of the processes that you want to take a look at. So let's say particles, and if you double click, it'll show you a line and the time it takes for that particle draw calls. You can see the time it takes for my particles to render, and it tells you exactly how many draw calls here I have for that process. So you can select different processes and see what's going on with each one of them. That way you can know what to attack when you're optimizing. One last thing that I forgot to mention is something really important. When you're trying to debug what you have on your scene, you can also use the view modes. And some of the good view modes are shader complexity, which will show you all your transparent materials and the cost, as well as the complexity of any material that, like if you have a lot of nodes in the material and it will be really heavy, it will show you this in different tones. Transparency, for the most part, are always gonna be on the red side and even the white, depending on how many transparent layers you have. Those cost a lot, and try to use it very, very sparingly. Here, I'm not using transparency. What I'm using is a node called Dither Temporal, which you can see in my material right here, which basically pokes holes to fake transparency. So it's lighter on the calculations rather than using transparency. And that's all for now. Leave a like, comment, and subscribe. Until the next one.